So, let's see. Here's one. This is 5.1, 19/7. 5.1, 19/7. If a person spends a three...
Good morning.
What?
Good morning.
Good morning. We already said good mornings, Miss Dennis. We're starting homework.
The computer hesitated. I couldn't say anything.
Well, we're glad you're here, Miss Dennis. We already talked about it.
I'm glad to be here.
All right. If a person spins a three-space spinner and then draws a playing card and checks his suit, describe the sample space of possible outcomes using 1, 2, 3 for the spinner outcomes. God, this is just ridiculous. And CDHS for the card outcomes. Make sure your answers reflect the order stated. Now, you could actually do this like so, make a sample space, and we got 1, 2, 3, and we've got, what? Hold on a second. I don't know why it's on that TV screen over there. For some reason it's not taking up the whole page. Why is it? What the heck? Anyway, I don't know why this is doing this. Let me pull that back up. For some reason, my whiteboard is not. There we go. It's some damn Russians. There we go. All right, so, and let me make this smaller. Now, I'm just doing a sample space. I don't know if they're going to ask for the sample space or what, and ABC or CDHS. CDHS. So C1, D1, H1, and S1. C2, D2, H2, S2. C3, D3, H3, and S3. So we got 12 possible outcomes.
Mr. McClure, is there an easier way to figure it out than like writing them all out individually?
Well, I don't know what it's asking. I'm looking to see what it's asking. So I'm doing this as a kind of kill two birds with one stone, showing you how to find a sample space as well as addressing the question. So I don't know. It says, well, that's the question. What the heck? Y'all just disappeared. Hold on. All right. This is the sample space. So you're going to have to actually write out the sample space. So that's the question. So here we go. And that's going to be C1. Now, if you can actually see the sample space, if that's what you're talking about, then knock yourself out. But again, I'm not here to teach people that know how to do it. I'm here to teach people that what? Don't know how to do it. So D1, D2, D3, and H1, H2, H3, and then S1, S2, S3. I think that's it, unless they want capital letters, and I'm not going to spend time doing that. All right?
The answer?
Say again?
That's the answer?
That should be the answers. That should be. Let's see.
What?
What?
Are you going to check it?
Yeah. That's the answers. Does it matter whether I put C1 or 1C? No. Doesn't matter. Same thing. I think the reason it didn't like my answer was because I put lowercase c's, and in math, that's a no-no. I admit that. Okay?
Does it matter what order you put them in?
No.
Okay.
Okay? So could that be a test question? No, because I don't like that type question.
Of course, because it's easy.
I'm sorry, what?
Seems easy.
Oh, you like that question?
It seems easy. I don't know.
Okay, well, I'll put it on the test then.
No.
No.
Next question. 5.121/8. 5.121/8. According to a certain country's Department of Education, 43.7% of 3-year-olds are enrolled in daycare. What is the probability that a randomly selected 3-year-old is enrolled in daycare? Well, that would be 43.7 over 100, but I don't understand type as a decimal. Okay, I'm a little bit confused here. According to a certain country's department, 43.7% of 3-year-olds are into 0.437. Okay, that's one of these questions that is so easy that it's what? That it's confusing.
Yeah, because I don't know what
Okay, somebody tell me what I just did.
wrote down the answer in the decimal.
I wrote down the percent as a what?
Decimal.
Decimal. I would not put this question on the test, or if I did, I'm sorry, because why? It would confuse you. Some of you would sit there like I did and say, what is this question asking? Well, what they want you to do, they want you to write the percent as a decimal. And yes, it's an easy question, but why wouldn't I put that on the test? Because it would confuse a lot of students. A lot of students would say, sit there and stare at it and skip it.
That would be.
I'm just saying that I don't like that question. I'll tell you what questions I like when I come up on them. Y'all know that. Okay, it's an easy question. Could it be a test question? Yes. Do I like it as a test question? No. So there you go. Next question. 5.127. You just sent number 19. Why'd you do that?
Me?
Miss Macagina, did you just send number 19?
Yeah, I did, because I put the answer in and it said I didn't get it in the correct form, so I want to get a perfect score.
All right, B1, B2, B3, B4, B5, B6. R1, R2, that's the answer.
But it said it wasn't correct.
Well, just put the B first. Since this is the smaller, I mean, put these first. 1B, 2B, 3B. If you did that on the test, I'd give you credit for it.
Okay.
Okay. So I would, if I was you, just put the number first.
Okay.
Okay. Not a big deal. That's not. I'm not going to fuss over that. 5.127/11. Somebody say something?
I was just saying, these are some weird questions.
Yeah. 5.127/11. A survey of 500 randomly selected high school students determined that 330 play organized sports. Well, somebody take 333 and divide it by 500. That's the answer. Round to the nearest thousand. So I'm going to do it because some of y'all won't answer me. So 333.
I got it.
Divide. That's okay. I'll do it. 500. Okay. I appreciate it. And that's 0.666. Oh my gosh. You've got to be kidding me. Y'all know we're doomed.
Satan gave us this number.
Yep. Okay. Interpret the probability. So 666 out of 1,000 play randomly organized sports. Play organized sports. So if 1,000, now why am I not picking Alpha? Why am I picking Bravo? Somebody look at the sentences. They say the same thing almost.
It says about.
Because sentence B says about instead of exactly.
Exactly.
You never use exactly in mathematics, okay? Unless you're talking about an algebraic equation and it's the only answer possible, okay? In probability, no, you never use the word exactly. You never use the word impossible. You never use the word perfect. You never use those words. So it would be about 666.
So for part A, you divided 500 by, sorry, I'm
Yeah, what is probability? How do you do probability? Probability, and I showed y'all this first day of class, or first day of chapter 5. Hold on. Let me pull up my handy dandy. Probability of an event is what? The number of times something happens over the number of times something is tried. So in this case, how many people, and you're always going to go, N is always going to be your denominator. So in this case, N is 500. And how many times did something actually happen? 333 actually play organized sports. So that would be your answer. Okay? It's always fraction. Next. 5.1, 36/14. Okay, in a national survey, where blah, 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 how often do you wear a seatbelt when riding a car and driven by someone else? The response frequencies appear in the table to the right. Construct a probability model for each. Okay, so I'm going to go to the spreadsheet. I'm only going to the spreadsheet so I can put it all on one page, okay? You can do this in your calculator. It says round to the nearest 1,000. Okay, I'm not using the spreadsheet because you have to. You do it in your calculator. First of all, what do you always find first with probability? Your denominator. And how do you find your denominator?
By adding them all up.
Adding them all up. Find N. So N is equal to, and I'm going to add all those up. There's N. So your relative frequencies or your relative whatever, I'm going to put it right here, relative frequency, which means your probability. Go ahead and just put a Q there. Well, frequency is Q, frequency, parentheses. Oh my goodness, I can't. Probability. There we go. Is equal to this number divided by this number. And everybody do that in your calculator right now. I want you to do all these probabilities. So go ahead and do that. Take the number 140 and divide by 4540 and so on. Go ahead and do that. That's your probabilities, please. And that's going to be bold and underlined. And this is going to have, get all those probabilities because I want everybody to make sure you understand where those come from. Relative frequency means you take that number and divide by the total. Take that number and divide by the total. Take that number and divide by the total, and so on. Now, if you want to change these into, you can do that by doing this. And you want to change them to percents, knock yourself out. Put a percent sign right here. And change all these, of course. Oh. All right, so you got a 3% chance, 8% chance, a 13% chance, a 24% chance, and a 52% chance. Remember, percentage stands for what? Chance. Probability is a decimal. Now, what did it say it wanted to round to? Round to the thousand. So I'm going to take my handy dandy calculator. You would do this in your mode in your calculator and put it to 3 decimal points. But you do whatever you want to. 3 decimal points. And there are your answers, depending on which one they asked for.
You have a work email.
So what does it ask for? It says never. Never would be 0.031. And it's going to ask for every single one. So I'm going to move this over. Hold on a second. The things I do for y'all. I hope y'all appreciate it.
We always appreciate it.
No, y'all don't. Y'all take me for granted.
Damn right.
What happened?
All right, now I'm going to make this small. There we go. Now we can type them in and not have to go back and forth. All right, so the next one is 0.076. The next one is 0.129. Please work with me. 0.129. The next one is 0.239. And the next one is 0.525. And what do they ask you next? Let's see what they ask. It says, would you consider it unusual to find, okay, let me erase this. Let me go down and pull up I'm going to explain something to y'all. And this is on standardized test, Miss Macagina. I want to bring this up because some of y'all know the empirical rule and y'all draw it out and you run a copy of it like I asked you to do. And when they ask you a question, you actually don't know what the heck you're talking about. I'm going to take my handy dandy green highlighter and I'm going to highlight normal. Does everybody understand that? Like I always do. I'm going to highlight normal. Now, the reason I'm doing this is because we really haven't gone over this, but we have. Y'all going, what is he talking about? Well, y'all know that the green area is what? What's the green area? It starts with an N. Normal, Hubert.
Normal.
Thank you. What's another word for normal? Not unusual. So tell me if my green area is not unusual, then what is this area right here?
Unusual.
Okay, so the pink areas, that's the unusual and the outliers. That is considered to be unusual. Outlier and unusual, both. So I'm going to put in red or pink, I'm going to put unusual. Now, there's a reason I'm showing you this now and not when I first showed it to you before. And that's not right. Unusual. I guess it is. Unusual. All right. Somebody tell me the percentage in pink.
5%.
Okay, good. All right. 5% is unusual. Does everybody understand what I just wrote down?
How'd you get 5%?
Add up the percentages. See the percentages? Add them up. And what do you get? You get 5%. How else can you write 5%?
0.05.
Okay, 0.05. Or 0.05 is unusual. Everybody agree with me?
Yes.
So, if I have a number, and I'm going to write this down, and I'm going to write this in red, that means you need to highlight it. If I have a probability of an event happening, and that probability is less than 0.05, then that event is what? Unusual. If I have a probability of an event, if I calculate the probability of an event and it is less than 0.05, then that means it falls into what? Those two areas. So probability of an event being less than 0.05. Probability of an event being less than 0.05. If you calculate a probability, and I call it the nickel rule, and I don't even know how to spell nickel.
N-I-C-K-E-L.
What?
You got it.
Okay. I call it the nickel rule because everybody knows what 0.05 is. That's a nickel, right? So if I give you a probability of 0.01, that's a penny. Is a penny greater than a nickel? No, so it's unusual. What about 12 cents? Well, 0.12 is greater than a nickel, so where does it fall? It falls in the green. So you need to write that down. If the probability of an event is greater than a nickel, actually greater than or equal to a nickel, then it is considered to be what? Normal or not unusual. Now, why am I showing you this now? Because in the future, you're going to be asked a question at the end of your homework or test, and it's going to say, is this event unusual? And you're going to take your probability, whatever your number of your probability is, and you're going to say, well, is it greater than or less than a nickel? And that's why. Now, I need somebody, if you don't understand, you better ask. Just remember a nickel. Nickel is 0.05. If your number, when you're finished with your problem, and your probability comes out to be 0.5, well, 50%, 50 cent is greater than a nickel, so it's normal. If it comes out to be 0.013, well, that's 1 cent. Is 1 cent greater than a nickel? No, so it's in the pink. Okay, that's what that means. So please make sure this rule right here is what you need to remember. If your probability is less than a nickel, then it's unusual. Now, let's go back to the question, and this is what it's going to look like. Exactly, whoever sent this question, you did a good job. So, would it be unusual to find a college student who what? Never. So what is our probability of never? Give me that probability in terms of cents.
3.1 cents.
3 cents. Is 3 cents greater than a nickel?
No.
So it's unusual. So which one says, it says, would it be unusual? Then it's either alpha or what? Charlie. Which one is it?
Charlie.
Charlie. Because your probability is less than a nickel. Now I want you to write that down. 0.03. And why did I not care about the 1? If you treat when you're testing for if it's normal or unusual, just use cents. This is 3 cents. This is 8 cents. This is 13 cents. This is 24 cents. This is 53 cents. Just mentally think of those numbers right there as cents. And then compare it to 5 cents. Compare it to a nickel. 8 cents is greater than a nickel, so that would be normal. That would be normal. That would be normal. That would be normal. This would be unusual. Okay? So you need to remember that. That right there is a test question. I would put that on the test in a heartbeat. And this question right here, they love this question on standardized tests. Next. And y'all are sending me questions during class. Great. Okay. 5.3, you're supposed to send questions when? Before class. All right, 5.3, 13 slash, but I'll take them. I'll take what I can get. Beggars can't be what? Choosers. I got people that have bad test grades and bad homework grades, and they won't send me a single question. 5.3, 13 slash 8. 5.3, 13 slash 8. All right, there we go. I'm going to let you write it down. Please write it down, please. It says about 13% of the population of a large country is allergic to pollen. Now, first of all, when I write that, you know what I'm going to say? This is what I'm going to say. I'm going to go over here to my handy dandy. And I'm going to write the following. And this is the way you should be thinking. When you write this question down, when you start working, this is what you should do. 13%, the probability of being allergic to something is equal to 0.13. Therefore, the probability of what is equal to 0.87. Somebody tell me what this is. It's called, starts with a C.
Correlation.
No, that's in chapter 4, but good guess. What?
Complementary.
Well, complementary in mathematics comes from complement. And somebody tell me what the definition of complement is. Anybody? It's in your book. You should have read it in your reading. I don't go over definitions very much after chapter 3. So after chapter 1 and 2. So that's something you should have got in your reading. What does complement mean?
Equaling 100%.
Is what makes up the whole. Good job. You actually read it. Wow. What makes up. Now that's the Hubertism definition. What makes up the whole. The complement is what makes up the whole. What were you given? You were given that the probability of being allergic is 0.13. So somebody tell me what this is. The probability of what?
Not being allergic.
And you put a big A red X through that. So we got the probability of being allergic is 13. and the probability of not being allergic is 0.87. Okay, now let's read the question. If two people are randomly selected, two people, what are the probabilities of the first being allergic and the what? Second being allergic. So let's write that down. A, probability of allergic and the probability of being allergic. What's my key word?
And
And means what? Multiplicative.
Multiplicative.
I appreciate you answering all the questions, Mr. Michelle, but we need more interaction from people.
Sorry.
So I'm asking the rest of the class to not let Mr. Michelle be the only person answering the questions, please. That's going to fall on deaf ears. I appreciate it, Mr. Michelle, but it's not going to do any good. You're still going to answer the questions because these people are weaned on a pickle, and there's there's nothing we can do about it.
Hey,
All right. So multiplicative law means that I'm going to do what with 0.13?
Multiply.
Multiply 0.13 times 0.13. Or 0.13 to the what?
Second power.
Second power.
How come you're doing it twice? Oh, two people.
Yep.
All right.
The question says, if two people are randomly selected, what is the probability of allergic and allergic? Allergic. And I'm going to take my handy dandy calculator because I know if I ask the class to do it, Mr. Michelle is the only one that's going to answer. So 0.13 raised to the second power is equal to 0.0169. And that is the probability of an allergic person and an allergic person being picked. So that means two people, right?
Yes.
Okay, I'm going to draw a number line on the next page. The reason I'm going to draw a number line is I know they're going to ask a question here in just a second because I know this question, I know this problem, and they're going to ask a question about at least or at most. And I want to go over that for you real quick because I want to make sure everybody understands what at least and at most means. Let's say we've got a number line here, and let's say 0, 1, 2, 3, 4, 5, and 6. Let's say we're talking about 6 people. Okay? And I'd ask you to tell me, what does at most 4, what does that actually mean? What does this mean?
Would it mean like less than or equal to 4?
Well, you're getting there. It means that the greatest number is what?
4.
I'm going to put here the greatest number is 4. That's what that means. So if you were actually to graph at most 4, you would highlight 4 and then you would draw a shade where?
Down to the 0.
Down to the 0. Good. And that would entail these 4 numbers, or these 1, 2, 3, 4, 5 numbers. That's at most 4. All right, now we're going to draw another number line. And we're going to call this at least 2. 0, 1, 2, 3, 4, 5, and 6. And somebody tell me, what does at least 2 really mean in layman's terms? Not the greatest number is blank, but what?
The lowest number is 2.
The lowest number is 2. So I'm going to shade 2, and I'll do this in blue since I don't use blue very much. And right now my camera's, there it goes. And I'm going to highlight 2. And what numbers am I going to highlight?
2 down to 0.
3. At least 2 means the lowest number is 2. So what does that mean?
Go up high.
Everything to the right. So this set includes 3, 2, 3, 4, 5, 6. Actually, it doesn't include 2. So I'm going to put an X through because it says at least 2. At least 2 are equal to. We're not gonna split hairs right now. I'm trying to get you to understand what these two things mean. Okay. So at most 4 means that the greatest number is 4. At least 2 means that the least number is 2. All right. So I want you to understand those two terms. All right. So I'm going to go back to the question. And I'm going to draw a number line that deals with our question. So far, our question, oh gosh. Yes, I'm OCD when it comes to making, okay. 0, 1, 2. All right, so far, we've been asked, what is the probability of 2? And the probability of 2 people being picked for allergies is 0.0169. Does everybody understand what I just drew on the board? Now, read the next part of the question. It says, what is the probability at least 1 is allergic to pollen? At least 1. So what does at least 1 mean?
1.
That means the smallest number is what?
1.
Okay, so let's write that down. At least 1 means the smallest number is 1. So I want you to graph that. Somebody tell me what the shade and what the, now we're dealing with bodies, so there's no decimals here as far as people. So I'm going to highlight what?
1.
And
1 and 2.
And 2. Because at least 1 in this question means 1 and what? 2. So I've got to do something with the probability of 1 and the probability of 2. Okay, so let's look at it again. It said, what is the probability at least 1 is allergic? So I'm going to rewrite that. What is the probability of 1 or more? Oh my gosh. What's that word?
Or.
What does OR stand for?
The addition.
Addition. Addition.
That's for addition.
So what am I gonna do?
Add.
I'm gonna add the probability of 1 plus the probability of what?
2.
2. Probability of 1 plus the probability of 2. So what is the probability of 1?
0.13.
0.13 plus 0.0169. And that should be your answer. Well, the probability that both will be is 4 decimal places, 0.0169. 0.0169. And what is the probability of at least 1? Somebody add those two together and tell me what you get. 0.1469.
Where
Yes,
you
sir.
get that?
I got.
Okay, they're going to do the complement. All right. They're doing it a different way. Hold on. They're going to do 1 minus 0.87 is what they're doing. Okay, let me explain it to you another way. They're using the complement in another way. They're using 0.87. Okay, hold on. Because you can do it, and the answer is a little bit different. So the complement of not getting, not allergic. I don't know how to spell allergic. Okay, the complement of 0.87 is not allergic. What is the probability of at least 1 is allergic? That's going to be equal to at least 1 is going to be equal to 1 minus 0.87 to the second power. And remember, that's going to be how many are allergic. At least 1 means that the lowest number is 1. Technically, this right here is the probability of 0. All right? The probability of 0. So somebody do that in your calculator. Somebody take 1 minus, what is 0.87 rate? I'll do it. 0.87 raised to the second power. 0.7569. And 1 minus that, second answer, is 0.2431. And that should be your answer.
I don't get that.
I don't either.
I don't get that problem.
I don't understand why they do it that way, but I guarantee you, watch it be right. 2431.
I have a quick question.
Yes.
Why did you square the 0.87 again?
Because what is 0.87? 0.87 is not allergic. All right. We found in A the 2 being allergic. In A, we found the 2 being allergic. All right. In A, we found the 2 people being allergic. So technically, this right here is the complement of A, of part A. Okay. We found A to be 2 being allergic.
I can't even see what you're doing.
Okay, it's hard for me to go back and forth. I'm sorry.
It's okay.
All right. In part A, we found 2 people being allergic. The complement of being allergic is 0.87. So the complement of 2 being allergic is 2 being not what? Allergic. And 2, this is right here, this is 2 being not allergic. And I took 1 and I subtracted the probability of 2 being not allergic. That's where the 0.87 comes from. This is not one of my favorite questions, and I do not put this on the test because it confuses a lot of students. So my suggestion to you when you do this problem, so I was trying to explain it to you, and then they turn around and do it the opposite way. So my suggestion is to take the complement of the original question, take the complement, square it, and subtract it from 1. So I'm going to write that down for you. For part B, take the complement of part A, and square it. And subtract from 1. Okay? Take the complement of A, which is 0.87, square it, and subtract it from 1. I agree with the first part of this question. The first part of this question is pretty simple. The second part, I don't agree with the way they do it because I don't think it makes sense the way they do it. But if you actually think about it, the complement of being allergic is 0.87. So 1 minus being allergic, not being allergic, is being allergic. And it's like they're going through the back door. And that's what they're doing right here. All right, let's go to the next one. I hope the next one's a whole lot better. That one's yucky. And they signed us out. And I don't know which one that was. Was that 17? Well, I'm going to assume it was. 5.322. Y'all settle down, please. 5.322/12. I don't think this is the one we need to go to next, is it? Let me look at the next, the 5.13. Let me see if that's the one we just went over. Okay. I'm looking to see. I don't think that's it. Which one did we just do? That's why I tell you all the numbers.
You said 5.13.
5.313.
Yeah.
Thank you. Now that would have saved us a couple of minutes if y'all would have told me that to begin with. Thank y'all. All right, so this one is 5.315/9. 5.315/9. A test to determine whether a certain antibody is present is 0.997. Well, I'm going to write that down first. Antibody, the probability of an antibody present is equal to 0.997. Now, I'm going to write that down first. This means that the test will accurately come back negative if the antibody is not present in the test subject 99 point. That's just an explanation. All right. The probability of a test coming back positive when the antibody is not present, a false positive, is 0.003, which is the complement of the antibody being present. So this is the first thing that I would write down. I told you that in the last problem right there. So what am I going to put through the second anti-present? I'm going to put a big red what? A big red X. Okay, so you've got the probability and its complement. Probability and its complement. So now let's go back to the question. It says, suppose the test is given to 4 randomly selected people. 4 randomly selected people. I'm just writing that down. So out of all this confunction right here, does everybody see all of that right there?
Mm-hmm.
All of that right here. Out of all of that, 3 sentences. Looks like a paragraph. This is what you get. That's what you get. So what am I telling you to do when you see a problem like this? Get it down to what you need. Okay? Get it down to what you need. This is the only thing that is important in that question. Now let's read the question. The first one says, what is the probability that the test comes back negative for all 4 people? So that would be negative and negative and negative and negative. So A would be probability of negative and the probability of negative and the probability of negative and the probability of negative.
So it would be 0.003 to the 4th.
It should be. Does it say negative? Yeah. Wait a minute. No. Okay, read this. A test to determine whether a certain antibody is present. This means that the test will accurately come back what?
Negative.
Negative. A false positive is 0.003. So come back negative would be 0.997 to the what?
That one would be the 4th.
So 0.997 to the 4th power. And I'm going to take my handy dandy calculator. 0.997 raised to the 4th power. And what does it say round to? So I can round. It says round to 4 decimal places. So 0.9981. 0.9981. So I'm going to type that in. 0.9981. And let's see what they get. Did I not type in? Oh, I typed in. What did I type in? I typed in 9981 and it's 9881. I'm sorry. I must have wrote it down wrong. Let me look at the calculator. 9881. My bad. 9881. I wrote down the wrong number. Or I wrote a wrong number. All right. Now what does it say? At least 1 positive. B. At least 1 positive. At least 1 positive. And that's going to be, we're going to take 1 minus 0.997 raised to the 4th power. Because at least 1 positive means 0, basically. All right, so at least 1, or that would be 1 minus 0.9997 raised to the 4th power. And I'm going to take my handy dandy calculator, and I'm going to do 1 minus, and that answer right there, second answer, and that's 0.0119. 0.0119. And let's write that down. Let's put that in the answer. 0.0119. Hopefully I didn't type that one in wrong. So I'm going to put this right here for you to put in your notes. At least one positive. I'm going to take 1 and I'm going to subtract A, part A. For part A, I got 0.9881. And I subtracted it from this right here, 1 minus 0.9881, and that's equal to 0.0119. Is this a test question? The first part is. I like the first part of the question. Okay. Next one.
Are we over time?
Are we? I don't know.
We're 10. We're 6
But
minutes.
y'all need to tell me these things. We're 1 minute over, I think, ain't we? I don't know. All
We're
right.
6 minutes over.
I'm sorry. So that's what happens when you don't communicate. Thank you. Y'all shut her down and have a good weekend, and we'll see y'all Monday, okay?
Okay.
You too. Thank you.
Have a
Thanks,
good
Victor.
day.
Have a good weekend.
You have a good weekend too.
Have a good weekend.
Bye-bye.
Be safe.
You too. Bye-bye.
Bye.